Hello. So welcome to the first video of phase 2. I'm going to explain a lot of things in this video, and I'm going to save some of the information for the later videos. I'm actually looking at a 3-part video to explain phase 2. There were a lot of changes both in the database level and at the code level, so I'm going to explain all of it as much as possible so that we won't get lost in the we won't get lost while trying to get to know the program and run the programs to get our work done. So okay, so I'm in the Sherlock directory, and I'm saying python main.py. Okay, so I have already started MongoDB in the backend. So as you can see, in phase 2, there are new menu items, new top-level menu items. There are cases, clusters, and admin menu. Okay, these are the 3 top-level items in the main menu. I'm going to explain the database first, and the changes in the database, and then we will slowly move to cases, clusters, and changes in the new crawl, which is option 1 here, and then we will touch upon admin menu as well. Okay, so as of now I'm going to get out of this menu. Yes, I'm sure. I'm going to say Mongo, and then I'm going to say use Sherlock. I'm going to say show collections. So there are quite a few database tables. App tokens. App tokens is for storing the social media application tokens. As you know, we are not directly scraping any social media website. What we are trying to do is we are trying to register our application with the social media websites, and then we are getting the data from the social media websites through API. So there is no we are not hiding any ways or means through which we are getting all this data. Okay, it's all there for anybody to see. They just need to get appropriate permissions. And the way the reason why we are doing it through API and not through crawling the websites is that if you go through API, the data that is gotten is a lot cleaner than you directly accessing the website, and then crawling the website, and then parsing all the HTML, and then gleaning the data from the downloaded HTML. And using API, you basically get all this data through XML or JSON or formats that are pretty easy to get the data out of. So what we do is, and there's these social media websites, they do not actually let you crawl the they do not let you crawl the websites that easily. They usually put a tab on limit on how much you can get it from the public websites before you get banned. Okay, there's always a case where they will go through their logs, and then they will try to ban the IP addresses which are crawling all the data from Facebook or Twitter or LinkedIn and all of the social media websites. So this basically is a much more cleaner way, and then it's always scalable and cleaner, scalable, and we do not resort to illegal ways of doing things, and everybody knows how it is done. Using API, everybody knows how it is done. and I mean you can always present the data in any forum, and then people would not have any problems with getting to know how you actually gotten the data. Okay. And on top of that, right now we are using API keys that are good for development and testing, but when we go production, we have to replace them with something not too obvious. Like for example, you said that we should not be using law, investigation, or any kind of words that actually give away who we are. Right? We have to be smart enough to hide the fact that we are representing a law firm or some sort of an investigation agency or something like that. Okay, so that comes later. What we have to do is just basically update the app tokens here, app tokens table, and we'll be able to understand which tokens need to be modified and how they need to be modified and all of that. So let us see if we can go into app tokens table and see if we can find anything that is meaningful. Okay, as you can see, the ID _ID is something that MongoDB provides for any record that has been inserted. We do not insert anything with this key. Okay, this is auto inserted by the MongoDB itself, and you can see there is Facebook, Twitter, and yeah, as of now there are Facebook and Twitter. We do not have LinkedIn and Google Plus. I mean, there is no data. Although the keys are present, there are no data present for these keys. So the key for the application token for the token as well as the key, they are interchangeable. There isn't any difference between a key and a token. Okay. And in Facebook we have something called application token or application key that is permanent, and you can use this. It's a two-part key basically. So this one is the application key, and this one is the application secret. And if you combine these two, and in fact this is not something that I have done, the Facebook provides this as a permanent key. So if you were to register a new application or a new account in Facebook that is primarily geared towards getting the data out of the profiles and all of that, you will also be given the same kind of a key, albeit the application key and the application secret will be different, obviously, right? Similarly, Twitter has a multi-part keys, and it goes like this. There is a consumer key, consumer secret, access token key, access token secret. I really do not understand why Twitter has such a laborious way of authenticating an application. It all boils down to getting the data out of Twitter, right? So obviously they choose to have a very different way in they choose to have a different approach in granting the access to the applications. As of now, we have just Facebook and Twitter. We do not have LinkedIn and Google Plus. But once we decide to scale it to other social media websites like these two, we can always go back and request application keys or application tokens. So that basically sums up what we have in app tokens table. Now there are three tables related to cases. Okay, as you can see, cases is a top level object. A case is a top level object, and once I go into the case module, I'm going to explain how a case is structured and all of that. So at the database level, we have three different tables for three related tables for cases. So I'm going to start off with the cases table here. db.cases.find . Okay. So again, we have underscore ID, which is given out by MongoDB. We don't have to bother about that. So we have something called status, which is in progress or completed or abandoned. These are the three statuses that are present for a given case. Okay. I mean, it obviously it makes sense, right? You know, when the case is started, when you enter a case inside a DB, it will by default it will have its case as in progress. And depending upon how the case is turning out to be, it will either be abandoned or it might be completed. When I say completed, I'm assuming that it is successful. Okay, abandoned is something that, you know, there are no new leads in the case, and basically it's a dead end, and there are no more leads or no more progress is being maintained in the case. So basically you don't want to waste time on this case, and you want to move on to a new case, but before moving on you just want to you just want to have a closure for this case, no matter what kind of a closure it is. So I'm saying that, you know, you can say abandoned. Now when I say abandoned, it doesn't mean that you cannot reopen the case and all of that. Obviously, you know, when you have a NoSQL database, the way, I mean, you can play with it in ways that are unimaginable. Basically, you know, you can increase the number of fields, decrease the number of fields, change the data types of the fields, mix and match with other kinds of data types. You know, the possibilities are endless. So and there's nobody's actually, you know, you saying that, oh, once a case is abandoned you cannot go back and change it and all of that. This is all up to us. You know, we have created it, so we have the flexibility to change it in whichever way we want it, right? So so you can to answer the question which you might get is, you know, once a case is abandoned, it doesn't mean that, you know, it's abandoned. Okay, it means that, you know, you can always go back and, you know, open it and then add new leads, new data for a case as and when they are available. Right. So cases table is a top level table, and cases leads and clients are basically, they are sub objects for a case. Okay, case is a top level object, and you have leads and clients related to a case. So cases contain the absolute minimum information that is available for a given case. Now when you open a case, you may not have any leads. You may not even have, you may not have enough information for a client, okay, about a client rather. So what you would like to do is, you know, you want to start off a case, and by the way, this is all my assumption, okay, and you are free to correct me, and you are free to change it in whichever way you want to. You know, this is what I know I have come up with. You know, it doesn't make anything final. That's what I mean to say. You know, this is all what I have understood when you have described about a case. You know, this is what I have come up with, and you're free to correct me, and you're free to suggest me any changes on how a case should be structured in a database, and how you want to actually get information out of a case object and all of that. So status, the cases table is the primary table, and then case leads and case clients are sub objects for a given case. Okay. And description is like, you know, a short text on what this case is all about, and then you're free to add any kind of data to it. There is no structure, and obviously when you see a NoSQL database, obviously there is no structure in schema as well as in the way we are defining the data, right? You know, you can have any kind of structure, and all the logic is at the application level, right? So there is no structure on how to describe on how to give a proper description to a case. You can in fact leave it empty if you want to. Date added is when the case is added, inside the database, and type is again it is something that I have come up with. I've thought that okay, there could be civil cases, there could be criminal cases, so these are the two types that I think would be there, and again there is no table, there is no list that I'm checking against with the type of the case that you are entering. You can enter any kind of case here. Although in the UI, when I show the UI, you will immediately see that I'm saying that in the parentheses I'm saying that it's a civil case or it's a criminal case and all of that. But you are free to mention the kind of case that this case belongs to. Okay. And later on, maybe like I said earlier, you're free to correct me if I'm wrong. Okay, and obviously no offense is taken, because this is something that I have come up with. Okay, and ID is basically what is the case ID. This ID is entirely different from the ID that you see here. Okay, this is the MongoDB ID. Irrespective of whether you give this ID or not, this ID is always present for a given record inside MongoDB. And then there is a name for the case. Again, name is something that you can come up with. Any descriptive name would do, and related information for a case can always be given in the description. Okay, over here. And as of now, there are two case objects here, two case objects, and and we can see leads and as well as clients. So let me show you if there are any leads for the cases. Case leads. Oh, there are quite a few. And I have done this a long time ago, so I don't remember. My memory is rusty when it comes to enter whatever I have entered the data, right? And I do not remember it. So you can see the case information over here. There is a priority, and all these things will be clear once we go to the UI of cases. Okay, I'm going to explain the case objects. In fact, after explaining the database schema, I'm going to explain the case objects. And there's a priority for a lead. Like when you are getting the leads, you can rank a given lead. So you could be having the most important lead for a case, least important, probably not that so important, and that kind of leads will always be there. So I'm giving you something called a rank or a priority. Okay, both the terms are interchangeable, and I'm saying that the priority can be from 1 to 5. Okay, and 1 being the highest and 5 being the lowest. And the source. Who is the source? Basically, where did you get this lead information from? Is it the person himself who has given you the lead? You could have gotten this lead from several different several different people. A source is basically a source basically tells you where did you get this lead information from. Okay, that's what a source is all about. Info is like, is there any extra info for this lead? So any descriptive information, any meta information that you would like to give for this lead, so you can mention that in the info column. Name. So what is the name for this lead? If this person whom you consider as a lead, if he himself has given you that information, then the source could itself be the name of the person. The same name could actually end up here as well. Okay, the name of the lead could actually be the same person as the source. Okay, so I'm just saying something over here. So do not think that I'm kind of racist or white supremacist or something like that. So I'm just giving a name here. Okay, it doesn't mean anything. and date known. So when did you know about this lead? When was the first time? I mean, at what date? What is the date timestamp for this particular lead? You might remember that, okay, on this particular day, probably around 2 o'clock in the noon, or maybe 3 o'clock, or something like that, right? So you can mention that information here. Again, there is no structure or something like that, so you can give the date over here. Date known over here, and date added is like date added and date known may not be the same. The reason is you might be taking the lead information in your notebook, right? You may not be you may not be entering that information directly as the lead is speaking to you, or as the lead is known to you. You may not have access to your laptop or any other computing device, right? So you might be taking that in the notes, and then you might actually, one fine day you sit on the table and you start typing all the lead informations, right? So a date added is like, when did you add this information to the database, to the Mongo database, to the Sherlock database. Description. So description and info, they're basically one and the same, but in description you are actually describing the first the most pertinent information for a given lead, like what the lead has told you, right? You will just type in all that information in the description. Okay, it is the lead information itself. And info is basically something like, what have you gathered from the lead? Are there any things that you have gathered? Do you think something different, or basically off with this particular lead, or something like traits or characteristics or traits, or things that you have observed as a person when the lead is telling you about the information that you wanted to know. So basically info is something that you have observed without the lead telling you anything, and it's like a notes about the it's like the meta notes. Okay, notes about the notes. Okay, so description is something that you have taken while the lead is talking to you, or you have gathered yourself by researching and all of that. So that is the difference between a description and an info. And ID is, again, ID is what the record information, the key information that I'm actually creating while creating the case lead. And the case ID, basically the case ID is something that it's a foreign key to the cases table. So if it says 2, so this particular lead is related to this record. Okay. So that basically sums up the case leads. So I'm going to talk about case clients now. Now, who is a case client? Case client is somebody who is actually asking you to investigate a particular case. So those are your clients. Again, the information that you see here may not be totally relevant and may not be useful to record information about a client. But this is something. So, something has to be recorded, right? There somewhere we have to start. So I basically came up with this information, and again, like I said earlier, we are free to change it, and there won't be much impact on the code as well. All the changes will be, obviously they won't be charged, and you don't have to pay anything for the changes, because this is something that we have already agreed upon, and changes are something that will keep coming on, and I'm always happy to accommodate your changes. Okay, fine. So the name of the client, the URL is like, if this person or the entity has a URL that we can reach out to, and then we basically record that website information over here. Case ID is like, again, the foreign key to the case. Phone of the client, phone number of the client, and location, where is this client located, when did you add this client, and the ID is something like a key, record key for this case client. Okay, so this basically sums up all the information related to a case. again, we let's go back to the tables that are present in the database. So let's see runs info. So let's see runs info. Okay, then we'll go to Sherlock clusters, and then I guess we can go to the cases, and then we go to clusters and admin menu and all of that. Okay, so runs info. So what is runs info? Okay, a run info is basically when you are remember I told you about session IDs. Okay, session ID is basically, it will tell you, it will differentiate, I mean it's a key which tells you how many times a page has been crawled, right? So it tells you only about the pages in a given project. In fact, a project has a crawl site, and then a crawl site has a list of pages, web pages, right? So each page has a different session ID. Okay, that session ID is basically is getting incremented as and when a new page or a new crawl has been done on a given website. Okay, so a session ID is there to basically track the historical information for a given page. Has this page has it changed in its lifetime? If so, what has changed in this page, and that kind of a thing. So so a session ID helps us to track that information. Okay, but there wasn't any key for us to actually tell you how many times a crawl has been done on a given website, right? So that information was lacking in phase 1. Although I thought that I started off with session ID being exactly that, right? For example, it will help us tell how many times a crawl has been done on a given website. That did not actually work out well, because a pages in a given website might also have versions. Now these versions need to be tracked, and when you want to track something, you need to give a counter, right? So so that's where the session ID came handy. And obviously we did not have to we did not have the need to track the number of runs, number of crawls for a given website. Okay, that was there wasn't any need for such a thing in phase 1. But obviously in phase 2 things got changed, and they changed majorly, and we needed to have something to track the number of crawls for a given website. So as you can see here, runs info is a table to track just that, how many crawls have been done on a given website which is a part of a given project. Okay, you can see the project here, P star, RID is the run ID, site is staratlaw.com, and a run can be done multiple times in a day. Okay, for every 5 seconds, every 10 minutes, every every twice in a day, thrice in a day, depending on how frequently the website is getting changed. Social media websites are a prime example for this, because they change quite often. People who are extremely active in their social in their social life, obviously like students and teenagers and celebrities and so on and so forth, they have a very active life, and they their social media web pages are extremely busy, and they often get updated. So when you have such a thing, you want to increase the frequency with which we are crawling a given website. Now that website is could be anything. It could be a social media website, it could be a normal website, it could be anything for that matter, which is crawlable, trackable, indexable, sortable, and things like that. Okay, any given internet property is something that that can be that can have all these attributes, trackable, sortable, indexable, and all of that. So in a given day we will have several runs, and these RID, which is short for run ID, will tell you how many times this website has been crawled so far. It is not telling you when this website was crawled the last time. That information can be gotten from the projects table, runs info table. I failed to remember. Projects info table. Projects info table will tell you that information. Okay, so when was the last time this website has been crawled? That information will be readily given out by projects info table. And IT stands for if there is more information for this table, you can get that information by typing IT. So it goes on and on and on, because Tarot Law is a website. It's a website which has been I've been using this website to track as an example website to tell you how this cases, clusters, and projects, crawling, and everything works. Okay, so I'm going to stop right here. So runs info table is basically used by the Sherlock checker program. As soon as Sherlock checker runs, it inserts a new record inside this table, and it increments it checks to which project this crawl site belongs to, and what is the current run ID for this particular project, and it's going to increment that run ID, and then it's going to insert that information into the runs info table. Okay, let's go back to other tables. Okay, and we have clusters. Sherlock clusters happens to be the table, the main table, which is used for recording all the cluster related information. Now, as you know already, clusters are a collection of documents. Now, these documents could be anywhere. They could be present in one single project, they could be present in multiple projects, they could belong to one particular crawl site, or they could belong to multiple crawl sites and multiple websites. So a cluster is basically an umbrella which acts for which basically it acts like an umbrella for all these documents which are scattered across multiple websites in multiple projects. Now this is a maximum scenario, so to speak. That means it's a scenario where you hit the boundary, upper threshold. Basically, a cluster having documents which are spread across multiple crawl sites and multiple projects. The minimum scenario is all of them belonging to one particular crawl site in one particular project. Obviously, there isn't any need to have a cluster in such a case, because everything is present in a crawl site, and that information can already be gotten from the crawl sites table. You don't actually need a cluster for such a thing. And also, there's another important trait for a cluster. A cluster is a grouping of documents. This is something that I have come up with to reduce the confusion related to a cluster. So a cluster is an object which has a uniform purpose. Okay, all of these documents which are present in a cluster, they serve a common purpose. Okay, so let's say you would have multiple projects to deal with a case, right? There could be multiple projects to deal with a case. Obviously, you want the documents present. You want the document present in these websites to be grouped together. In phase 1, you couldn't have done that. So in phase 2, thanks for your suggestion, by the way. This is something that it actually makes the whole thing easier to grapple with. And so a cluster basically combines all these documents in multiple projects, in multiple websites, under a single umbrella. So you can always go and check, okay, which documents are part of this cluster. Can we add some more documents? Can you remove these documents? Can we update the documents? You can do such things when you have a cluster. So and also you can see that there is a difference. The naming convention that I have come up with a cluster. I mean, if you see clusters, I have named the table as Sherlock clusters, and for cases I have named them just as cases. Now, why did I do that? The reason is, when you have NoSQL databases, a cluster is like a cluster is a computer term which actually means that you have a collection of machines. Now, when you're talking NoSQL databases and a web application or a command line application, or in fact any application which has a NoSQL database, there's a good chance that you will have a cluster of machines working like a distributed database system, and you don't want to get confused with that particular cluster, a hardware cluster from a database table, right? Even if you want to explain this to others, they should not think that, okay, you might be storing all the hardware information, all the machine related information in this particular table, right? If you just say clusters, they would understand it like that. So I mean, there's a chance that they would understand this cluster as like that, but no, our cluster is entirely different. Our cluster is geared towards our own software, like our own application, right? So that's why I have named this thing as Sherlock clusters, and that I retained the name of the object as it is, cases. Okay, so again, Sherlock cluster is a main table, and we have absolute minimum information that is needed to identify a cluster, and there are other subtables which actually are related with the foreign key, parent key, foreign key, primary key approach, and just like the cases. So I'm going to explain those tables as well. Now you have date. When did the cluster get created? What is the nodes? I mean, is there any nodes for this cluster? And just like some information which is helpful to understand and identify what this cluster is all about, because cluster is it's a database, it's a top level object on its own. It's like a first class citizen on its own, right? So it's not part of a project, it's not part of a crawl site. So you would like to know to which project or to which projects this particular cluster is related to, right? So that information can be given in the notes. Notes is like a descriptive section where you can just give enough information possible to understand this cluster and what it is doing and that kind of a thing. And ID again is like row ID for this particular row. Name is the name of the cluster itself. It can be as descriptive as possible, or something like you can come up with an alphanumeric code, just like robots and all these movies have, right? X125, X2, X-Men, or something like that, right? So sorry, that was a poor joke, but you can have such kind of naming convention as well. And again, I just want to stress this fact. All this information, all this structuring of the tables, structuring of the data, and all these things are basically something that I have come up with. There is no error checking, like a name of the cluster should have at least 4 characters, or the date should be actually a valid date, note should have enough characters to actually make it a note or something like that. So there is no such thing done here, because once we have a common understanding of how big a notes can be, how old a date can be, and what can be sensible input for name, right? So all this information is something that we can only come up with while we are testing this out, and then we are using this on a day-to-day basis, and then we will know, okay, names can have at least 2 characters or probably 15 characters maximum, and then we can write as much information as possible in the notes section. Okay. So let's go to the related tables for clusters. db dot we have cluster documents, clusters underscore docs. Find. Oh, so there are no documents right now, but we can add them. We can add documents from the crawl sites table. We can always do that. And what else? I guess those are the tables that are new to phase 2. I'm gonna quit from here, and then I'm going to explain a little bit about I guess this is exit parenthesis. I'm going to explain a little bit. Oh, sorry, I guess it is quit. Yeah. So I'm going to explain a little bit about the modules. Let me go to Sherlock core. Okay, so Sherlock diff.py is a module which deals with differences between 2 crawls of a given website. It will tell you what has changed in between 2 given website crawls. Okay, that is what Sherlock diff does. I mean, all the related functions to do the diffing are present in this particular module. Sherlock notes tells you everything. I mean, it has all the helper methods to help you take notes on any given topic. Okay. Sherlock status will tell you the status of all the running crawls. Okay, currently which are going on in the machine. Sherlock search will tell you about has all the helper methods for letting you do the search. Search can happen in multiple locations and in multiple objects like cases, clusters, projects, crawl sites, downloaded data, notes, leads, and clients. So a search is basically it's the most pervasive function of Sherlock. Okay, and PYC, obviously they're all compiled code, so you can just ignore all these things. And Sherlock browser will basically let you browse all the Sherlock objects, cases, clusters, crawl sites, projects, nodes. I mean, the list is endless. Okay, and Sherlock clusters has all the methods to let you play with clusters. Sherlock cases, the same thing but with cases. And Sherlock requirements is the module which deals with all the prerequisites for Sherlock to run properly. Okay, like all the modules, all the whether all the backend services are running or not. For example, MongoDB, is it running or not? So basically, Sherlock requirements has all these methods to check each of these things. Okay, Sherlock util has all the utility methods which are used. I mean, all the common functions that are used across all the Sherlock code base I have basically put under Sherlock util module. And forget about Sherlock Social. Sherlock Social doesn't have much, and I thought that we would come up with something which is I mean we would create a module to crawl all the social media websites and all of that, but I thought that it's better to include such information with the existing modules itself. Why transfer all this information into a separate module, because every social website has its own behavior, so there is no common behavior as such, so there's no reason to group them under a single module. Okay, Sherlock admin is the admin menu. You have seen the admin menu, right? So that particular section is handled by Sherlock admin. Sherlock config is the main menu that you see as soon as you say Python main.py. That is where I mean that whole menu is handled by Sherlock config. Sherlock crawl is the module which handles all the crawling related information, the new crawls and adding new websites to the existing projects and that kind of a thing. It's basically the option number 1 in the main menu. SM crawl is the social media website crawler. It has Facebook. It has Facebook and Twitter crawling methods. This is not a common. You might notice some contradiction here. Earlier I was talking about Sherlock Social, and now I am talking about Sherlock Social Media Crawl. SM crawl is nothing but social media crawl. Now, Sherlock Social, I thought that I would have common functionality for all the social media websites, but that wasn't the case. When as I dug through deeper and deeper inside the social media websites, most of them have their own DNA. There's no commonality as such. Twitter has a different behavior, Facebook has a different behavior, and you cannot combine these two. So I thought that when I have it was immature, I would say it was immature of me to think that social media websites can have common functionality and we can just write a class to do or handle all this thing. But that wasn't the case. So Sherlock SM crawl basically has functions which deal with one single social media website. So Facebook has a Facebook method, Twitter has a Twitter method, Google Plus, LinkedIn have their own methods. Okay, and that basically sums up about Sherlock SM crawl. Sherlock model is for it's all the database access layer, database operations. All the database operations are present in Sherlock model. Sherlock cases, Sherlock clusters, they are obviously they are for the respective top level case and cluster objects. And you will see tilde. These files, these are backup files for Emacs. They have nothing to do with the functionality of Sherlock itself. Okay, and there are some minor changes in Sherlock checker. So let me go back to the main directory and let me explain. And as you have noticed, this does not touch anything about the running of the top level objects like cases, clusters, and admin menu. I just want to create 2 more videos or maybe 1 video to combine these 2 into cases and clusters into 1 video, and then I'll explain to you how these things can be done. Okay, so I'm gonna say less Sherlock checker, Sherlock checker.py, and so basically this checks whether initially it checks for whether all these modules are installed or not, and that kind of thing, prerequisites and all of that. And then it branches off it gets the site name. Okay, the site name is the same thing. You will get the ID of the site. And by the way, when you see Sherlock Checker, it is not run by the user. Okay, always remember that it is run by the cron job, and I'm going to explain the structure of the cron job as well, because there seems to be some confusion there. So I'm going to clear up that as well. And you take the basically Sherlock Checker runs. The external interface of Sherlock Checker hasn't changed. You give the site ID, crawl site ID to the Sherlock Checker, and what Sherlock Checker does in phase 2 is it checks whether this site is a SM site. Okay, SM site meaning whether it's a social media website, and if it's a social media website, the way it handles the Sherlock crawl is entirely different, because as you can see, I'm giving the site name to the Sherlock SM crawl object. Okay, this does not happen for a regular non-social media website. As you can see here, I have commented it out, and have put enough comments so that you won't get lost in looking for the trying to understand the source code and things like that. So non-social media website, it is the same thing like it was. It hasn't changed much. I would say it hasn't changed at all, because we have two top-level crawl modules: Sherlock crawl, which is basically the same thing from phase 1. There's no difference, and Sherlock SM crawl, which is like social media crawl, and it has functions for methods for various social media outlets. Okay, so that's how Sherlock Checker runs, and I'm going to show you the structure of and mind you, everything else is same. There isn't any difference in the phase 2 for Sherlock Checker, except that you actually check whether the website is a excuse me, you check whether this website is a social media website or not. Other than that, there isn't any difference. Everything remains same. Okay.